Here's the Math 2 Unit 0 practice test. So for number 1, we're looking at the diagram, naming the angle pair, solving for the variable, and then plugging it in to find the measure of each angle. So starting with number 1, we see that there's this box here, which indicates that this is a 90-degree angle. And when two angles add up to 90, those are complementary angles. And complementary angles have a sum of 90. So we're going to do x minus 13 plus 3x plus 1 is equal to 90. And combine like terms. So we have x and 3x makes 4x. And then we have negative 13 and 1, which is negative 12. And now we're going to add 12 to both sides. So we have 4x is equal to 102. And then the last step, divide by 4. So you get x equals 25.5. So they do want us to plug it back in to find the measure of each angle. So if I plug it in for x here, to get xyw, we have 25.5 minus 13, which gives me 12.5. And then I plug it in for this one. So 3 times 25.5 plus 1 gives me 77.5. And those are both degrees. So one way you can check to make sure you had this right, these two should add up, we know, to 90 degrees. All right, taking a look at number 2. So for number 2, I see that we have two angles that form a straight angle, which means this is a linear pair, or you can say they're supplementary. And we know that supplementary angles have a sum of 180 degrees. So 3 plus 4y plus y minus 28 is equal to 180. So again, we're going to combine like terms. So we have 4y and y makes 5y. And then 3 and negative 28 is negative 25. Add 25 to both sides. We have 5y is equal to 205. And then divide by 5. We get y is equal to 41. Just like before, we're going to plug it in to find the measure of each angle. So ABC is this obtuse angle. So 3 plus 4 times 41. You get 167. So angle ABC is 167 degrees. And then we can plug it in for y to find the acute angle. So that's going to be 41 minus 28. Which is 13. So CBD is 13 degrees. All right, looking at number 3. So number 3, I see that we have intersecting lines, and the angles that we're looking at are directly across from each other. So these are going to be vertical angles. And remember that vertical angles are congruent, which means that the angle measures are equal. So we have 3z plus 5 equals 7z minus 11. So I like to get all my variables on one side first. So I'm going to subtract 3z. Everything comes down. So 5 is equal to 4z minus 11. Then I'm going to add 11 to get all my constants together. So 5 plus 11 is 16. And then divide by 4. So z is equal to 4. Now we plug it in. So 3 times 4 plus 5 is equal to 17. So PRS should be 17. And when we plug it into QRT, we should get the same thing because we know these are congruent. So 7 times 4 minus 11 is also 17. So measure of QRT is 17 degrees as well. Number 4, we're just identifying. So we want to look at the figure to name the following. A linear pair, remember, two angles that form a straight line. So there's a few that we can do. We could do 4 and 5 are a linear pair. We can say 5 and 6 are a linear pair, 7 and 6, and 4 and 7. So I'm going to do angle 4 and angle 5. We want a pair of vertical angles. So vertical angles, we're looking for two intersecting lines or two intersecting straight angles. And we're looking at the angles across from each other. So we could do 4 and 6, or you can do 7 and 5. So I'll do angle 7 and angle 5. Last thing we're looking for here is a pair of complementary angles. Complementary angles are two angles that form a corner. So I see this box right here, and the two angles that form that box is going to be angle 1 and angle 2. So now we're looking at angle pairs formed by parallel lines. They want us to name it as well as state the relationship if they're congruent, supplementary, or complementary. So alternate interior. So here's our transversal. We're looking for angles that are on the opposite sides of the transversal and on the inside. Remember, we want one angle from this top bunch and one angle from the bottom. So 3 and 6 could work for alternate interior. So angle 3 and angle 6. Remember that alternate interior angles are congruent, meaning they're equal. All right, looking at the next one, same side interior. So same side means on the same side of the transversal and on the inside. So 3 and 5 is one pair, 4 and 6 is the other. So I'm going to say angle 3 and angle 5. Remember that same side interior angles is the one angle pair where they are supplementary, meaning they add up to 180 degrees. Next thing we're looking for is alternate exterior, so on opposite sides of the transversal, but on the outside. So 2 and 7 would work, and 1 and 8. So I'm going to say angle 1 and angle 8. And those are also congruent. And then lastly, the pair of corresponding angles. So corresponding angles are the angles that match position. So if we think of this as being one set and this being one set, we're looking for angles that are in the same position. So 1 and 5 are corresponding because they're both in the top left-hand corner. We have 2 and 6 would be corresponding, 3 and 7, and 4 and 8. So I'll say angle 4 and angle 8. And since they match, we know that those are also congruent. All right, for question number 6, they want us to solve for the variable in the diagram, and then they want us to find the measure of angle A and angle B. So we do need to show our work and justify using academic vocabulary. So first thing let's do is let's solve for the variable. So we have this angle right here and this angle right here. So that's these are going to be same side interior angles. Remember, same side interior angles are supplementary. So I'm going to abbreviate same side interior. So they are supplementary. So to solve for z, we're going to set them equal to 180. So 4z plus 14 plus 14z plus 4 is equal to 180 degrees. So now we're going to combine like terms. Our z's combine together to make 18z, and our numbers combine together to make 18. Subtract 18. So we have 18z equals 162. And then lastly, divide by 18. So we get z is equal to 9. So now that we have that, we can plug that in our diagram to figure out the measures of angle A and angle B. So first I'm going to plug it in for this angle up here, this acute angle. So 4 times 9 plus 14. That gives me 50 degrees. And I'm going to also plug it into the obtuse angle just to see what that is. So 14 times 9 plus 4 should give us, if this is 50, then we know that this is 130. Okay, so let's see how that helps us to find the measure of angle A. Well, I see that that A and 4z plus 4 are vertical angles, so we know they're congruent. So if this angle right here is 50 degrees, that means the measure of angle A is also 50 degrees. And I'm going to say that's because A is vertical to 4z plus 14. And then to find the measure of angle B, oops. Let me rewrite this. So the measure of angle A is equal to 50 degrees. There we go. And then if we look at angle A and angle B, these are corresponding angles, and corresponding angles are congruent, which means that the measure of angle B is also going to be 50 degrees because it's corresponding with A. All right, let's take a look at question number 7. So question number 7, same thing. We're first going to solve for the variable. So we see that we have this angle right here and this angle right here, and those are alternate interior angles. And we know the alternate interior angles are congruent. So to solve for x, we're going to set this equal. So 7x minus 8 equals 5x plus 10. So minus 5x from both sides to get my variables together. So 2x minus 8 is equal to 10. Now I'm going to add 8. So 2x is equal to 18, and then divide by 2. So x is equal to 9. Now we want to use that to find the measure of angle A. So first let's plug in x. So 7 times 9 minus 8 gives us 55 degrees. And remember that if this is 55, then we know that this is 55 because they're alternate interior angles. But if we want to find angle A and B, we know that angle A and this angle right here are a linear pair because they form a straight angle, which means we can do 180 minus 55, which is 125, to get the measure of angle A. Because it's supplementary, or a linear pair, with the 7x minus 8. Okay, so if the measure of angle A is 125, we actually know that the measure of angle B is also 125, and that's because it's alternate interior with angle A. All right, let's take a look at the last example here. So the last example, we're doing the same thing. We're solving for the angle pair. So let's first look at the angles. We have the 8x plus 12 and the 9x plus 11. I see my parallel lines. I see my transversal. They're both in the same position, so these are corresponding. And corresponding angles are congruent. So we're going to do 8x plus 12 is equal to 9x plus 1. I'm going to get my variables on one side, subtract 8x. So that's x plus 1 minus 1 minus 1. So we get x is equal to 11. All right, so now I'm going to go ahead and plug it in here. So it's going to be 8 times 11 plus 12. That's 88 plus 12, which is going to be 100 degrees. Well, if we look at this angle right here and A, these are vertical, right? I have my intersecting lines, they're across from each other. So if this is 100 degrees, that means the measure of angle A is also 100. And the reason would be because it's vertical to the 8x plus 12 angle. And then if we look at B, the relationship between B and this angle is that they form a linear pair, right? I have a straight angle here, I have 9x plus 1, and I have B. We know that 9x plus 1, this angle is 100 degrees. So to find the measure of angle B, we're just going to do 180 minus 100. That's 80 degrees. So the measure of angle B is 80 degrees. And the reason is because it's a linear pair with the 9x plus 1 angle. Okay, or you can say it's supplementary. All right, in question number 9, we're finding the values of x, y, and z. So here's what we need to remember. We need to remember that there's 180 degrees. The interior angles of a triangle add up to 90 degrees. So we're going to be using triangle sum theorem here. So to find the value of x, we're going to add together 25 plus 65, which is 90. And then we're going to subtract that from 180. So 180 minus 90 is going to be 90. So the measure, so x is going to be 90 degrees. And then I'm going to say that I use triangle sum theorem to solve for x. So now that we know that x is 90, I actually know that y is also 90 because it's vertical to x. So x and y are vertical, and we know that vertical angles are congruent. All right, so if I know that y is 90 degrees, again, I can use triangle sum theorem. So I can do 90 plus 35, which is 125, and then subtract that from 180. So that means z is equal to 55 degrees. And so I use triangle sum theorem again. All right, let's look at number 10. So kind of the same idea here. First, we need to solve for x, because we can't solve for y or z since we only know one angle in this triangle. However, I know two angles here. And if I know two angles, we can add them together. So 28 plus 97, which is 125, and subtract from 180. So that means x is 55 degrees. Okay, this one I'm not going to explain. I'll just say it verbally. So x is 55 degrees. The next thing we're going to do is figure out what y is. Well, I see that I have three angles here, and these three angles form a straight line. If we've solved for x and we know that x is 55 degrees, we can say, do essentially what we just did before. We can add the two angles, so 55 plus 65, which is 120, and subtract from 180, since we know that they form a straight angle. So 180 minus 120 is equal to 60 degrees. So y is equal to 60 degrees. All right, last one here. So if we know that y is 60, now we can use triangle sum theorem one more time. Do 60 plus 32, which is 92, and then subtract from 180, which is going to be 88 degrees. Oops. So z is equal to 88 degrees using triangle sum theorem. All right, number 11, we're using Pythagorean theorem. So Pythagorean theorem is a squared plus b squared equals c squared. So it's important to make sure that we identify what is the hypotenuse in these triangles, because we know that the hypotenuse is the thing that goes by itself when we're doing Pythagorean theorem. So for A, it's going to be x squared plus 5 squared is equal to 12 squared. Leg squared plus leg squared is the hypotenuse squared. So this is x squared plus 25 is equal to 144. Subtract 25. We get 119. And then square root. So it does say round to the nearest 10, so that's going to be approximately 10.9. All right, for B, again, we have leg squared, hypotenuse, so x squared plus 11 squared is equal to 12 squared. 11 squared is 121, 12 squared is 144. Subtract again, since we're solving for a leg. So we have x squared is equal to 23, and then square root both sides. Square root of 23 in your calculator is approximately 4.8. All right, last problem. It says Adrian leaves the house to go to school. He walks 200 meters west and 125 meters north. So if we have a direction, we have north, east, south, west. So if we draw a diagram, if he walks 200 meters west, here's Adrian, 200 meters west, and then he walks 125 meters north. This is where he's at. And then when he walks home from school, he can walk in a straight line back home, which means he's traveling along the hypotenuse. So here we have a triangle. We want to know what is the total distance he walks going to and from school each day. So essentially, we're looking for the perimeter of this triangle. First thing we need to do is we need to solve for the hypotenuse, which is here. So we're going to use Pythagorean theorem. So 125, let me use a different color here. So 125 squared plus 200 squared is equal to x squared. So we get 15625 plus 40,000. So when we add those together, we get 55625 is equal to x squared. So we square root in Pythagorean theorem. We get x is approximately 235.8 meters. So, but since we want to know the total distance he walks, we're looking basically for the perimeter of this triangle. So we're going to add together all the parts. So he walks 125 meters plus 200 meters plus the hypotenuse, which is 235.8 meters. We get 560.8 meters. Okay, word problem should have word answers. So I'm going to say Adrian walks a total of 560.8 meters each day.